All right, let's go ahead and let's take a peek at our problem for our Pepsi. So let's look at a schematic of the Pepsi below, made of aluminum. The length is this, the diameter is this, thickness is this. You can see the Pepsi can strain gauge measures the strain in the long direction of the black rectangle. The strain measured, Pepsi can was pressurized. So the strain that was measured when the can was pressurized was 0.3%. What's the pressure difference? Okay, so we know that one coordinate system. So we'll see our direction here. And actually this is basically through the thickness. We can kind of see around. Yeah, we'll see this in just a second. Whether you put a stress in the 1 or 3 doesn't matter too much. But anyways, so our material is aluminum, so our Young's modulus is 100 gigapascals. Our nu is equal to 0.3. We're given a radius, and we're given a thickness, so if we're thin-walled, our R over T must be greater than or equal to 10. And if that's true, then our stress tensor will be in the 2 direction, it's longitudinal. You could pick 1 or 3, because again, we're looking at the hoop direction. But I would say, if it were me, I would pick the 3, the hoop. And then our strain tensor will look very similar. Strain in the L. I forgot to charge I'm going to charge my pen after this. So let's go ahead. I'm going to quit the kernel and everything. And actually, I'm going to create a new little kernel. Because I'm going to do my y is equal to 100 times 10 to the 9. My nu is equal to 0.4. My radius is equal to 1 times 10 to the minus 2. And my thickness is equal to 0.5 times 10 to the minus 3. So I want to make sure R over T is this. Sig H is equal to del P times R over T. My sig L is equal to del P, actually sig H divided by 2. My EH is equal to 1 divided by y times sig H minus nu times sig L. My EL is equal to 1 divided by y times sig L minus nu times sig H. And, all right, I kind of lost my mind there. Okay, so we know that the strain, when it's pressurized, was 0.3%, and then that's measured in the long direction of this strain gauge, so along this direction. So we know that our solve EL set equal to 0.003, because we need to move it 2 decimal places. So that'll be our del P. So del P is equal to this. So now what we'll do is we have everything else now. Sig H, sig L, EH, EL. There we go. We got it. Everything else is done. So we are good to go. So what was the pressure difference? We solved for that. Full stress and strain tensor, we have those values here. What's the value of maximum shear stress? That's always going to be in the plane sig H minus sig L divided by 2. And here in the 2. What's the rotation to get this state? 45 degrees. List the three principal stress values and the rotation to get there. Rotation is 0. Sigma 1 is always sigma H. Sigma 2 is always sigma L. Sigma 3 is going to be 0. Explain fundamentally why we can ignore stress in one direction for this problem. We could ignore the through thickness because we're assuming that the radius is much larger than the thickness, so we can treat it effectively like a surface. So that's the key idea there. So there we go. That's what we've got. So we are ready to go. Fantastic. Good problem. You definitely want to start on that thin wall pressure vessel problem. We'll see you in the next video. Thanks. Bye.